Hi guys, today we're going to cover section 3.3, slope of a line and the rate of change. And the things to know, we're going to talk about the idea of slope, the formula, and parallel perpendicular lines and the applications. So first, let's talk about what is slope. Slope by definition, again, in this case, I'm going to think about the regular definition, not math, right? Slope is simply the steepness of a line or a hill, or some kind of grade. Okay, so slope is steepness of a hill or grade. Okay, now the way we define slope is rise over run. Okay, so this is a definition we're going to go with for now. And we can use the rise over run to figure out the slope of a line if you're given a graph. So to figure out the slope of a line by using 2 points on the graph, first you can pick a starting point and an end point. And the way to get from the starting point to the end point is you can either go up and down, left or right. So if I'm using this as my starting point, to get to the end point, I have to go 1 down and 3 to the right. Okay, but when you're going down, remember, right, just like when you're plotting points, anytime you're going down, you're talking it's negative. So in this case, we have -1 for going down and 3 to the right. And 3 in this case will be positive, just like on the number line. So my slope will be -1/3. Okay. Now again, you could switch the points. So for example, instead of calling the first point starting point and the second point the end point, you could technically switch things around. So now if I call this point the starting point and this point the end point, right? The slope of the line, it should be the same, right? Because all we did is just switching points, because we go up 1 and 3 to the left. Right, if you go up, it's positive. You go to the left, it's negative. So the slope you're going to get is 1/-3, which is the same as -1/3, or -1/3. Okay? So as long as you have 2 points on the line, right, you can use rise over run to figure out the slope. Let's try another problem. All right, so now let's go ahead and try this second problem right here. Notice for this problem, I did not give you any points on the graph. So you need to figure out where the points are. And the best way to pick the points is this. Find the points that lie on the corner of the grid. We want to try to find the points that's on the corner of the grid. We don't want anything that's in the middle of the line and not on the corner, because otherwise you have to estimate. And we're going to try really hard not to estimate points. So I'm going to pick this point right here. And I'm also going to pick this point right here. So my slope for the second problem is going to be, let me erase a little bit of space over here so I can got some room to work. So it doesn't matter which point you pick, but I'm going to pick this. I'm going to start with this point right here. So it's going to be up 1, 2, 3, 4. It's going to be up 4. And 1, 2, 3 to the right. So my slope will be up 4, which is +4, and my run will be a +3 because I'm going to the right. So the slope will be 4/3. Okay. Again, when you find the 2 points, make sure you find the points that's on the corner of the grid. It's going to make your life a lot easier. All right. Let's go ahead and keep going. All right, here we go. A ladder is leaning against the wall. The top of the ladder is 8 feet above the ground, and the bottom of the ladder is 2 feet away from the base of the wall. What is the slope of the ladder? So in this case, let's go ahead and draw a picture. Now, depending on how you draw the wall, right, you could have a wall with a ladder leaning this way, or a wall with a ladder leaning this way. Okay, so I'm going to pick this one for our application. Now, it doesn't really matter which one you pick, but in this case, we're going to pick this. We're going to pick the first one. Okay, so let me get rid of the second picture. So that means, now let's put the numbers in the picture. We know the ladder is 8 feet above the ground, so which means from here to here is 8. And the bottom of the ladder is 2 feet from the base. So which means from to here, here's from the base to the wall is 2. And again, drawing is not to scale. So what is the slope of the ladder? Well, if I start from the bottom of the ladder to the top of the ladder, that means I had to go 2 to the right and 8 up. So my slope will be 8 over 2. Rise over run. Go up 8 and 2 to the right, or 4 over 1. So the slope is 4 over 1, or just 4. Okay. Yeah. So again, if you have a picture, sometimes it might be easier to just do rise over run. Okay, let's go ahead and move on to the formula. So a lot of times, if you don't have a picture, they might give you a couple points, and that's when the slope formula is being used. The formula is y2 minus y1 over x2 minus x1. Notice I had a typo. It should be a y2, not a y3. Now, you get the value of x1, y1, x2, y2 from 2 points. So usually they'll give you 2 points. And so to calculate the slope, all you have to do is just plug it in. So let's go ahead and try some of these. Let's look at part C. Now, instead of keep writing slope, we're going to use the letter M. It's internationally recognized. So slope will be y2 minus y1 over x2 minus x1. We'll start using this notation right here. Okay. So let's look at part C. Part C, we're using the points 1, 2, and -4, -5. So all I'm going to do is I'm just going to plug the numbers in. Now, it does not matter which one you call it, x1, y1, x2, y2, but if it helps you, feel free to label it. So with that labels, let's plug the numbers in. y2 minus y1 means -5 minus 2. Over x2, which is -4, minus x1, which is 1. Notice, I'm not going to worry about, switching signs and everything. All I'm going to worry about for now is just go ahead and plug in numbers. Okay? So -5 minus 2 is a -7. -4 minus 1 is a -5. So my final answer is -7 over -5, or just regular 7 over 5. Okay. All right, let's go ahead and move on to the next problem, part D. So again, part D, we have the line V goes through the points 0, 4, and 0, -1. And what's the slope? So I'm just going to plug in the values. So M equal my y2 minus y1 over x2 minus x1. So I'm going to call this x1, x2, y1, y2. So I have -1 minus 4 over 0 minus 0, which is -5/0. Now remember, in test 1, we said anything divided by 0 is undefined. Okay, so this line right here has an undefined slope. Okay, and let's go ahead and move to part E. So let me erase a few more things. I need a little bit more space. So for part E, this time we're looking at the 2 points. Again, we're looking at -2, -3, and phi -3. So we're looking at -2, -3, and the phi and -3. So slope equal y2 minus y1 over x2 minus x1. Plugging the numbers, I have -3 minus -3. -3 minus -3 over phi minus a -2. On the top, -3 minus -3, you get 0. On the bottom, I get 5 minus a -2, which is the same as 5 plus 2. You get 7. Again, from test 1, 0 divided by anything that's not 0 is going to be 0. Okay, so the slope for the part D is undefined. The slope for part E is 0. Okay, again, remember, 0 is a valid point, is a value. 0 and undefined are different. Okay. All right. So hopefully at least everybody have some chance to work on some of these problems. Again, the slope formula is very important. Make sure you know how to use it, and make sure when you plug in numbers that you keep track of all the signs and remember how to add and subtract integers. All right, so now let me erase the rest of this, and you can rewind the video to you can see the rest. But I want to do a little bit more focus on the part D and E first. Notice for line B, if you graph it, what you end up getting is you get 0, 4, 1, 2, 3, 4, and you get 0, -1, which is down here. When you connect the two dots together, what you end up getting is a vertical line. If you look at part E, you have -2, -3. And you have phi -3. 1, 2, 3, 4, 5. Connect the dot. And now let's think about their slope. In part D, we already found out that it is a undefined. Whereas part E, we found out that this is 0. So keep this in mind. If you have a vertical line, the slope is undefined. If you have a horizontal line, the slope is 0. Okay, this is just something that I want to make sure I point out. All right, number 4, parallel lines and perpendicular lines. Just remember, parallel lines are the two lines that never touches. So which means if two lines never touch, they must have same steepness. Parallel lines have same steepness. So that means they must have same slope. Okay, so parallel lines have same slope. Now for perpendicular, I'm just gonna give to you. So slopes are opposite reciprocal. For example, if the slope of the line is 3/2, the slope that is perpendicular to it is going to be -2/3. Notice the sign change and also the reciprocal. So the fraction flipped. Okay. So that's one way to check. The second way is the slope, when you multiply them together, they have to equal to -1. Okay, so these are the two ways to check to see if the two lines are perpendicular. You multiply their slopes together, there has to be -1, or the slopes has to be opposite reciprocal. It means the same thing. Okay, all right, so here we go. Let's go ahead and look at the last couple story problems. The application problem, rate versus rate of change. Now remember the rate of change means slope. And let's talk about ratio versus rate. So ratio versus rate. Now, the two main difference between the ratio versus rate is that, yes, both things are comparing to, so both are comparing two quantities. However, rate compares two quantities that have different types of units. For example, miles over hour, dollar per hour. Okay, these are two different type of quantities with different units. Whereas ratio, you're comparing two quantities, but the units are the same. Or at least I should say the same type of units. Okay. So this is a definition that we need to know, because later on we'll use it. Now let's go ahead and dive into part B. Part B, the retail sales of men's skincare were 81.7 million in 2011 and 89.5 million in 2014. Find the average rate of change and describe what it means. Again, average rate of change means slope. So which means we need 2 points. So we need 2 points to find slope. Now we have a problem. We're dealing with two things here. We're dealing with money and we're dealing with year. So the question here naturally would be, well, do I do money then year as my point? Or do I do year and money as my point? Which one do I use? Okay. So in this case, what we need to figure out is that how to make sense of this. And the way we talk about in class is that when you're dealing with x and y, right, the x is called the independent, and the y is called the dependent. Okay, so the question you need to ask yourself is this: does money depends on the year, or does the year depend on money? And we discussed about this in class. We realized that, well, the amount of money that that it earned for the skincare, it depends on what year it is, right? The year does not depend on the money. It's the money that depends on the year. So which means if the money depends on the year, that means the money is the dependent variable. And that means the independent, which is the year. So we're going to be looking at the points using this format. Okay, so which means here's our 2 points. We all have 2011, comma, 81.7 million. I'm not gonna write down all the zeros. Or we're gonna have 2014, and we're gonna have 2014 and 89.5. So now from here, plugging the values into the slope formula, and we'll be good to go. So slope is 89.5 minus 81.7 over 2014 minus 2011. Calculate that, and we will get, I need to calculate this really quick, so give me just a moment. Okay, let me see. You guys are probably faster than me on this one. So let's double check. See, 89.5 minus 81.7 is 7.8 over 2014 minus 2011 is 3. So 7.8 divided by 3 is 2.6. So this is going to be 2.6 over 1, but don't forget the labels. So we have $2.6 million over 1 year. So our slope is so our rate of change is $2.6 million per year. And notice this is a positive. This is a positive 2.6 over 1, which means we're increasing by $2.6 million per year. Okay. All right. Last problem. In district, student at ABC College pays $82 for 9 credits of classes and $11.76 for 12 credits of classes. Find the average rate of change and describe what this means. So again, we got to think about, does the money depends on the credit, or does credit depends on money? And in this case, we're going to have to say the money, the tuition depends on credit. Right, depends on the number of credits. So which means our point is going to be credit for X and the money for Y. So we have 9,882 and we have 12,1176. Throw this into a slope formula. We get 1176 minus 882 over 12 minus 9. Calculator, 1176 minus 882 is 1094 over 3. Make sure, oh, oops, that's not right. That is totally wrong. Let's try this again. 1176 minus 882, which is 294. That sounds more like it. And 294 divided by 3 is 98. So the slope is 98 over 1, $98 per 1 credit. So this is how much it costs per credit at this college. All right. So this is it. Any question you have, please let me know, and I will see you guys in class.